In this video we will look at common fractions, but before we do that, just a quick introduction on how to do mathematics. So number and copy the examples, ask your teacher if there are any steps that you do not understand, number the questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. So whenever you see a pause button, you have to pause the video and do the question on your own first, and then when you're done, press play and mark your answer. Then after you mark your answers, if it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now, in this video, just to give you an overview, we are going to look at multiplication and division of fractions. Then we're going to look at how to find the lowest common multiple. Then an addition and subtraction of fractions, multiple operations, squares, square roots, cubes, and cube roots, and then finally percentage. Now for the first example, example 1.1 on multiplication and division of fractions, the first thing we do, if we have multiplication of fractions, it's quite easy because all you have to do is you have to multiply the numerators together and you multiply the denominators together. That's if nothing can cancel out yet. So basically I'm just going to write A times C, which is AC, over B times D, which is BD, and then that is my final answer. So to look at that, when we have values, here we have 3 times 5, so this is going to give me 15 over 4 times 7, which is 28. Then for example 1.3, now this one says simplify, and we can now see that 6 and 15 both have a common factor of 3. So in order to simplify this, I can divide top and bottom with 3. Whatever I do at the top, I have to do at the bottom. So I can change fractions. If I want to get a bigger form, then I can multiply top and bottom. But we'll look at that a bit later. To simplify it, we divide with the highest common factor, and that is 3. So this is going to be 2 over 5. Then for example 1.4, here we have some variables. Now to simplify this, we see here we have 5 and 10. So 5 can go into itself once and into 10 2 times. Then there's a B at the top and a B at the bottom, so they can cancel each other. And then we can write it as A, because we don't need to write this 1, A over 2C. That's the values that are left. So whatever is remains at the top needs to go at the top, remains at the bottom, or the denominator needs to go at the denominator. And then if we have division of fractions, so whenever you have to divide fractions, you have to, the first thing you want to do is to change the division sign into a multiplication sign. And to do that, we call it flip and times, where we flip these to the numerator and denominator of the fraction that's right after the division sign. We flip that one around, and then we can change this division into multiplication. So this becomes A over B multiplied by D over C. And then we can just go ahead and say A times D is AD and B times C is BC, and that is our final answer there. Then for example 1.6, so now just an example with values. The first thing, if we see the division, we want to change it into a multiplication. So 6 over 8 multiplied by 2 over 3. Now here we can go ahead and multiply, but before we do that, I'm just going to simplify it first by dividing. As I can see here at the denominator, we've got a 3, and this numerator we have a 6. And 3 can go into itself once and into 6 twice. So you can cancel out or simplify top and bottom as long as one is in the denominator and one is in the numerator. So here we have 2 and 8. So 2 can go into itself once, and 2 can go into itself in 8 4 times. So we divided top and bottom with 2. Now I can write it as 2 times 1 is 2. And 4 times 1 is 4, but it's still not in its simplest form. We can take it further and say 2 can go into itself once and into 4 2 times. So now we are left with 1 over 2. And then for examples 1.7, so here we have division again. So first thing we're going to do is to change it into multiplication by saying 2x over y multiplied by 3y over 4. So let's see if we can first cancel out, because if you cancel out first before you do the multiplication, it makes your sum much simpler. So we have y that cancels, and then we have 2 can go into itself once and into 4 2 times. So if I multiply what is left, we've just got 1x or x, so x times 3 is 3x, and over here we just have 1 times 2, so that's just 2. So this is then our final answer there. Alright, so now do these 3 sums on your own, and when you're done, you can press play again to mark them. Alright, so for question 1.1, we have to simplify these fractions. So we have 16 x squared y to the power 3 over 12xy. Now, when we cancel these, if I have, for example, y to the power 3 over y, then it's the same as saying I've got y times y times y over y. So I can cancel 1 at the top with 1 at the bottom, and then I'm just left with y squared. Now, we're not always going to expand these expressions because that's going to take a lot of time. So I'm just going to cancel them by cancelling the exponent. So I'm going to say the one of these y's cancels with 1 at the top. So if I cancel 1 at the top, then I have 2 left. And one of these x's cancels with an x at the top, so I just have an x left because I had x squared. Now if I look at my coefficients, 12 and 16, I know 4 can go into both of them. So 4 goes into 12 3 times and 4 goes into 16 4 times. Alright, so I am left with 4xy squared, 4xy squared over just 3 over 3. And then for question 1.2, 22x squared y to the power 3 over 11x cubed y to the power 5. Alright, so first of all, let's see what we can cancel. Now 11 can go into both itself and into 22. So 11 goes into itself once and into 22 2 times. There's 2x squared and x to the power 3. So I can cancel 2 of these x. So I can cancel x squared completely and 2 at the denominator, which just leaves me with x. And then y to the power of 3. I can cancel y to the power 3 top and bottom. So there's 2 y's left in the denominator. So let's write down what's left. We've got 2 over here in the numerator. Then in the denominator we have this x left, and we have y squared. And then that is our final answer. Then finally for question 1.3, we have 18 e to the power 3 f g squared all over 9 e squared f g. Alright, so starting to cancel, 9 can go into itself once, into 18 twice. Then e to the power of 2, so we can cancel e squared at the most top and bottom, so that cancels. And then we have 1e left here at the bottom. Here we have f, so f can cancel top and bottom, and g can cancel 1 at the bottom and 1 at the top. So now just writing down what's left, we've got 2e and g. And at the bottom we just have we can just put a 1 because everything at the bottom was cancelled, so I can just simplify it to 2eg. Right, so for question 1.4, I've got 32x squared y to the power 3z over 64x cubed y cubed z squared. Okay, so let's start by cancelling. 32 can go into itself once and into 64 twice, so that cancels. That's 1, that's 2. Then if we move over to x, x squared can cancel over here and x squared here, so we just have that x left at the bottom. Then we've got y cubed top and bottom, so they can completely cancel with each other. And then z, one of these z's cancels, and then one of these cancel, so we just have z in the denominator. Alright, so what is left? We've got just a 1 or a placeholder over here, and then over here in the denominator we've got 2xz, so 2xz. So notice that whatever is left, if it's in the numerator, it stays in the numerator. In this case, we just have a placeholder, and the denominator, everybody here that was left over was part of the denominator, so we still have to keep it in the denominator. Okay, so then for question 1.5, I've got 2 over 3 times by 6 over 8. So before I multiply out my numbers, I'm first going to see if I can't cancel, because that would make my sum a lot easier. Then I wouldn't have such big numbers to work with. So 2 can go into itself once and into 8 4 times. 3 can go into itself once and into 6 2 times. I can again cancel, but I'm just at this point going to multiply out. 1 times 2 is 2, and 1 times 4 is 4. And then I'm going to say, okay, 2 can still go into itself once and into 4 2 times, so I'm left with a half. And then for question 1.6, 2x squared over y multiplied by y squared over 6x. All right, so once again, I'm just going to start by cancelling. I've got these coefficients where 2 can go into itself once and into 6 3 times. Y cancels at the denominator and with one of the y's at the numerator, and then x here can cancel with this one of these x's over here. All right, now before we multiply out, you can actually just write down what you've got left here. So here we only have x over 1 multiplied by y over 3, and then let's multiply it out. So then this is xy over 3. All right, so for question 1.7, we have 3a over b divided by 6 over b squared. Now, over here we have a division sign, so first thing we need to do is to change it into multiplication and flip these two around. We've got 3a over b multiplied by b squared over 6. Now we start by cancelling. 3 can go into itself once and into 6 2 times. Then b cancels with one of these b's, so there's just a b left. So what do we have left? We've got a over 1 times by b over 2. So multiplying that out will give us a b over 2. Then finally for question 1.8, I've got 2ab over c divided by 4ac. Now, because this is division, now the first thing I'm going to do is, here we have, this doesn't look like fraction, but what we can do is we can change it by saying, putting it over 1. So now we can work with it as a fraction. So whenever you have a number and you're busy working with fractions and you need to do calculations, put it over 1, then you can treat it as a fraction or work with it as a fraction. And now we can say 2ab over c times by 1 over 4ac. All right, so cancelling, now see there's a c there and there, but now we can't cancel those because they're both in the denominator. What we can cancel is we can say 2 can go into itself once and into 4 twice. A can cancel with this a, and then what do we have left? We've got b over c times by 1 over 2c. And multiplying that out, b times 1 is b, and c times by 2c is 2c squared. Right, question 1.9. So here, what do we need to start with is we need to do brackets first, if you remember. So we need to simplify inside the bracket first. Now, what I can do is I can start by cancelling. And what I can cancel, I can't actually cancel anything here because all the b's are at the top and all the a's here. So we can just simplify this one by multiplying it out. So I'm going to start here and say a squared over bc squared divided by, and notice I can't change this division sign yet because all of this is after, because it's in the brackets, everything inside the bracket is applicable to this division sign. So I first need to completely simplify this. So we have b times b squared is b to the power of 3, because remember we add our exponents, and then c squared over, that's c times c, then a squared times by a squared. If I add those exponents, I get a to the power of 4. Alright, so now we have this single fraction over here, and we can now change this division sign into multiplication. This one stays the same. Remember, only the one after the division sign changes. Then times by a to the power of 4 over b to the power of 3c squared. Let's see if we can cancel. So once again, we can't actually cancel because we have a b over here and here, but both denominators, c and c both in the denominator and a both in the numerator. So simply just multiply them out. We have a to the power of 2 times a to the power of 4, so that gives us a to the power of 6 over b to the power of 4, c to the power of 4. And then for question 1.10, now when we do these divisions and we have more than one division, we can immediately start by flipping them all around. So let's just say that this division is applicable to this fraction, so that one's going to flip that one around, and this division is applicable to this fraction, so that's going to flip that one around. So let's do that. So we have a squared over bc squared times by c squared over bc, and then times by a squared over b squared c. Alright, now that that is done, we can go ahead and cancel. We have a c squared over here, and we've got a c squared over here. So this c squared and this c squared can cancel. Then the only thing that's left at the top is a's, and there's no a's at the bottom. So basically we're just going to simplify by multiplying it out. A squared times by a squared is a to the power of 4, and then b times b times b squared, if this is to the power of 1, and we add all of these exponents, we get b to the power of 4, and then c times c is c squared. Okay, so that was multiplication and division of fractions. Next we move on to lowest common multiple. Now the example says determine the lowest common multiple of 6 and 8. So these are the steps that we follow to find the lowest common multiple. We list all the numbers that we want, that applies to, or that we want to find the lowest common multiple of. And then we do prime factorization. Now remember, prime factorization, you do that with the ladder method, where you have, and your prime factors are what? They are 2, 3, 5, 7. So all the numbers that can only be divided by itself and 1, those are your prime factors. So you start with the very first one and you say, can 2 go into 6? Yes. Put a 2 there, 2 goes into 6 3 times. And then you ask again, can 2 go into 3? So no, not without a remainder. So 2 is done. Then you move over to 3. So now, can 3 go into 3? So yes, 3 can go in. 3 goes into 3 once. And then the moment that you only have a 1 here, then you're done. So in short, we can write 6, according to its prime factors, 2 times by 3. Okay, so that was the one way that you can find prime factorization. That's a bit long for me sometimes. What I like to do is to say, I start with my 2, so I've got 8 here, and I say 2 can go into 8, yes. Then I say, okay, that's 2 times 4. Okay, so now we can break it up further. Now we can look at, now we already have that 2 there. Now we look at the 4. So can 2 go into 4? Yes, that then becomes 2 times 2 times 2. So this is where I took my 4 and I broke it up further into 2 times 2. Now all of these are prime factors. So just to write it down, we can write 2 to the power of 3. Okay, so now to find our lowest common multiple, we can now say, we take the basis. So what basis do we have in this case? So remember, here's our final prime factors for that one, and here's our final prime factors for this one. So we have a base of 2 and a base of 3. Now, when we compare these two, the one with the highest exponent, like we now compare 2 to the power of 1 and 2 to the power of 3, the one with the highest exponent, you write here. So 2 to the power of 3. Then say times, and then 3, the base of 3. This one doesn't even have a base of 3, so now we just write down, okay, 3 is our base, or base of 3 with highest exponent. and then this will be your lowest common multiple. If we multiply it out, it would be 8 times by 3, so this would be 24. All right. Now let's look at this example, 2.2, where we have to find the lowest common multiple of 36 and 24. So the one to find the prime factors, I'm just going to use the ladder method for 36. So remember, we've got 2, 3, 5, 7, 11, and so forth. So for 36, to find the prime factors, I'm going to say, can 2 go in there? Yes. How much is left? 18. And then can 2 go into 18? Yes. 2 goes into 18 9 times. Can 2 go into 9? No. So 2 is done. Then we move on to 3. Can 3 go into 9? Yes. 3 goes into 9 3 times. Can 3 go into 3? Yes. 3 goes into 3 once. All right. So now that we've reached 1, we can write this as our, or 36 is a product of prime factors. So this is then 2 times 2 times 3 times 3, or then we write it in its compact form, 2 to the power of 2 times 3 to the power of 2. And then over to 24. So this, I'm just going to do the other method again. 2 can go into 24, so this is 2 times 12. And then I can further break 12 now up into 2 times 6. So this is 2 times 6. All right, so I have this 2, so now I can break 6 further up into 2 times 2. So I just copy that, times 2 times 3. All right, so this then is equal to 2 to the power of 3 times by 3. Okay, now to find the lowest common multiple, I compare my two. So this is my one answer and that's my other answer. Now we've got bases of 2. This one has 2 to the power of 3, this one 2 to the power of 2. So I'm going to use 2 to the power of 3, which is the highest exponent. So I'm going to put it over here. Then I look at my 3's. This one has 3 to the power of 2, this one just has 3 to the power of 1. So I'm going to take 3 to the power of 2 and put it there. And then my lowest common multiple will be 8 times by 9. Okay, so this is then equal to 72. Right, now determine the lowest common multiple of 6a squared, b, and c. And then 8a, b, c, and 12a, b cubed. All right, so to break these up, 6 is just 2 times 3 times by that a squared, b times by b times by c. 8 is 2 times 4, and 4 is 2 times 2, so this is times by 2 times times a times b times c. 12 is 2 times 2 times 6, and 6 is 2 times 3 times by a times by b to the power of 3. Okay, now let's just complete this by writing it in its so this is still just 2 times 3 times a squared times b times c, where this is 2 to the power of 3 times a times b times c, and then 2 to the power of 2 times 3 times a times b cubed. All right, so now to get the lowest common multiple, I'm going to find my bases. So 2 to the power of 3 is my base of 2 with the highest exponent, so I write that, 2 to the power of 3, times, for the bases of 3, here we have to the power of 1 and to the power of 1, so both of them, highest one is just to the power of 3, and then for a, the highest exponent is a to the power of 2, or a squared. B, we've got the highest one as b to the power of 3, and then c, because c to the power of 1 is the highest. Now our lowest common denominator is 8 times by 3, so this is 24 a squared b to the power of 3 c. So here you pause the video again, do the question on your own, and play when you're done. So for question 2.1, I have 12 and 18. I need to find the lowest common multiple. So for the first one, I'm going to use the ladder method to find to write 12 as factor of prime factors. So 2 can go into 12 6 times, 2 can go into 6 3 times, 3 can go into 3 1 time. So this is then going to be 2 times 2 times 3. And then for 18, I'm going to use the method where I just say 2 times 9. So 2 can go into 18, that's 2 times 9. And 9 can further be broken up into 3 times 3. So this is 2 times 3 times 3. To write them in their compact form, we've got 2 to the power of 2 times by 3. And over here, we've got 2 times by 3 to the power of 2. Then my lowest common multiple will be, so between the two bases of 2, we've got 2 to the power of 2. Then times by, between these bases, 3 to the power of 2 is the highest. So this is then equal to 4 times 9, so that's equal to 36. Now for question 2.2, to find the lowest common multiple of 10a and 6ab. So if I break up 10a into its prime factors, I've got 2 times 5 times a, and 6 is 2 times 3 times a times b. And over here we have a 2, so my lowest common multiple is, so I've got a base of 2, and then 5, and then a, right? Then I've got over here, I've got a 3, I already have an a, and then a b. Now this, let's just go over this again, or in other words, if I compare my bases of 2, because remember I need to get every base involved. So if I have a base of 2, my highest is to the power of 1, both of them, and then a 5 to the power of 1, and then if we look at 3, there's this one is the highest, or the only one, 3, and then there's an a to the power of 1 and a b. Okay, so just to simplify this then, 2 times 5 is 10, times by 3, that's 30 a b. So for question 2.3, we need to find the lowest common multiple of 32 and of 12. So let's use the ladder method for 32. Now remember, I'm just doing one of each method so that you can choose which method you'd like to use. So if I have 32, then 2 goes into 32 16 times, 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4, 2 times 2 goes into itself once. So this one is then 2 times 2 times 2 times 2 times 2, and that's equal to 2 to the power of 5. For 12, I've got 2 times 6, which is, and then 6 broken up further is 2, so this 2, and then times by 6 broken up, 2 times 3 is equal to 2 squared times by 3. Okay, so my lowest common multiple then will be 2 to the power of 5, that's my base with the highest exponent, times by 3. Alright, so now that's 32 times by 3, so 30 times 3, that gives me 90, and then 2 times 3 is 6, so my final answer is 96 as my lowest common multiple. Then for question 2.4, we've got 3a squared b cubed, and then 9a cubed b, and then 12ab squared. Alright, so now for to break this up, we've got 3 times a squared times b to the power of 3. 9 is 3 squared times a cubed times b. 12 is 2 times by 6, and 6 is 2 times 3, so this is 2 squared times by 3 times a times b squared. Alright, so to get our lowest common multiple, we will look at all the bases. So let's start with base 2. 2 to the power of 2 is the highest. So next we look at the base 3. So from these 3, the highest one is 3 to the power of 2. So then I write 3 to the power of 2. Next we have a. So the highest one with base a is a to the power of 3. So that is then a to the power of 3. And then b, the highest one is b to the power of 3. So my lowest common multiple there would then be 4 times by 9. So this is going to be 36, a to the power of 3, b to the power of 3. Okay, so now that was lowest common multiple. And the biggest reason we actually did that now was so that we have the tools to apply when we have to add and subtract fractions. So our first example is then going to be express 2 over 3 plus 4 over 5 as a single fraction. And when we add fractions, we cannot add them unless the denominators are the same. So if I have 2 over 3 plus 4 over 5, I cannot add these two before I not change both the denominators into its lowest common multiple. So between 3 and 5, my lowest common multiple is 3 times by 5, or 15. So to get both of them to 15, I have to multiply this one with 5. And what I do at the bottom, I have to do at the top. So I cannot just multiply my denominator with 5. It's going to change the value of the fraction. But if I multiply top and bottom with 5, then I just get an equivalent fraction, so the value doesn't change. And over here, to get 3 to 15, I have to say times by 3, top and bottom. And then I can rewrite it as 10 over 15 plus 12 over 15. Now I'm in the position to be able to add these. So I add my numerators, but then my denominator stays the same. So 10 over 50. So 10 plus 12 gives me 22 over 15. And this now, because the numerator is bigger than the denominator, this is known as an improper fraction. So normally we can leave our answers like this unless if nothing is stated. But if they say leave your answer as a proper fraction, what we do then is to convert it to a proper fraction. We say 15 can go into 22 how many times? Once. And then what is left if I take away 15? Then I have 7 left. So then it's 7 over 15. So let's look at this example. We need to calculate 1 over 2 minus 3 over 4. So what is our lowest common multiple between 2 and 4? It's 4. So I multiply this one with 2, top and bottom, so that I can get both of them equal to 4. So this is then going to be 2 over 4 minus 3 over 4. So this is then 2 minus 3 all over 4. And 2 minus 3 gives me a negative value. So this then becomes negative 1 over 4. Or I can even write the negative in front of my fraction as minus 1 over 4. Then we have 3 over a plus 2 over b. So my lowest common multiple between a and b is ab. So I say times by b, top and bottom for this fraction, and times by a over here. Then I have 3b over ab plus 2a over ab. And then I can add them. Now remember, 3b and 2a aren't like terms. So to add them, I just write 3b plus 2a, but I can't actually simplify it over ab because these two can't add. You can't add unlike terms. So this will then be your final answer. All right, so now we have 2a minus 3 over c. Lowest common multiple between a and c is ac, so times by c, top and bottom, times by a, top and bottom. And this will then give me 2c over ac minus 3a over ac. So to simplify this further, we now have 2c minus 3a over AC. So here you can pause and then do these questions on your own and then plan mark them. Alright, so for question 3.1, I have 2 over 5 plus 7 over 5. Now, this one's quite easy because both of my denominators are the same, so I can just go ahead and add 2 plus 7 is 9 over 5. And then to simplify it even further, I can just write it as a proper fraction. 5 goes into 9 once, and 4 over 5 is left. Then question 3.2, so 2 over 5 minus 7 over 5. So here we have 2 minus 7 over 5. So 2 minus 7 gives me a negative number. It gives me minus 5 over 5. And to simplify it, we can cancel. 5 can go into itself once and once. So 1 over 1 is just 1. So my final answer is just minus 1. In question 3.3, I've got 1 over 2 minus 1 over 4 minus 1 over 8. Alright, so first thing we need to do is to get it over the lowest common multiple, and between 2, 4, and 8, it's 8, because 2 can go into 8, 4 can go into 8. Now to get 2 to 8, I have to multiply it by 4, top and bottom. To get 4 to 8, I multiply it by 2, top and bottom. So 4 over 8 minus 2 over 8 minus 1 over 8. So this then gives me 4 minus 2 minus another 1. So that is 1 over 8. Question 3.4. I have 1 over 8 plus 2 over 5. My lowest common multiple between these two is 8 times by 5, because if I break 8 up, it's 2 to the power 3, and 5 is just 5, so that's 2 to the power 3 times by 5. So this is then going to say times 5 times 5. Over here I say times 8 times 8. And then I have 5 over 40 plus 16 over 40. And this is then 5 plus 16 gives me 21 over 40. Then we go to question 3.5. I've got 2 over a plus 5 over a. So 2 plus 5 gives me 7 over a. That's my final answer. Then question 3.6. 2 over 5 plus 3 over 10. Now lowest common multiple is 10, so multiply by 2, top and bottom. Then I get 4 over 10 plus 3 over 10, and that gives me 7 over 10. Okay, so for question 3.7, I have 2 over 3 plus 2. Now, remember, if we have a number and we're working with fractions, to change it into a fraction, I just put it over 1. And then what I can do, or now that we have two fractions here, we have to get the lowest common multiple before we can, or the denominators needs to be the same before we can add them. And I can see the lowest common multiple or lowest common denominator between these two is 3. So I just times by 3, top and bottom over here, which then gives me 2 over 3 plus by, or added by 6 over 3. And then this 2 plus 6 gives me 8 over 3. Now, get it into a mixed fraction again. I will say 3 goes into 8 2 times, and then 2 over 3 is left. That's if I take 6 out. 2 over 3 is left. Then for question 3.8, I've got 2 over b minus 3 over b squared. Lowest common multiple between, lowest common denominator between b and b squared is b squared. So multiply by b, top and bottom. So this is then 2b over b squared minus 3 over b squared. So to simplify this, we say over long dividing line, 2b minus 3 over b squared. And notice we can't add these because they are not like terms. Okay, so that was addition and subtraction of fractions. Next we look at multiple operations. Now, these are your rules from BODMAS that we're going to run through. These aren't official rules, but they are just listed as rule 1, 2, and so on. So in the first rule, we say we see that a calculation in brackets must be done first. So an example of that is I've got this sum over here, and when I see these brackets, although we multiply first before we add, but these brackets mean that we need to add first. So I'm just going to rewrite this. So this is going to be half times by, and then I add these. So 3 plus 1 is 4, and then over 4. Because the denominators are the same, I could have just added them. Now I multiply. So I can start by cancelling when I multiply. So 4 can cancel with itself. So then we just have 1 over 1. And our final answer is just 1 times 1, which is 1, and 2 times 1. So this is just 1 over 2. Then for rule 2, we see that if we have a number raised to a power or an exponent, that is calculated first before you do any multiplication or division. So a very common error is people will multiply this 2 into or with this number first before they now that you can't do because of this square over here. You have to simplify this first, this whole with a square first before you can actually multiply or divide anything inside there. So to do that, we write down our minus 2, and then to multiply or to square, remember a negative square. So if I have minus 1 and I square it, it's the same as minus 1 times minus 1, and then that becomes plus 1. All right, so if I square a negative number, it becomes a plus. And then when you square a bracket, you have to square the numerator and the denominator. So you have to say 1 squared is 1, and 2 squared is 4. All right, so now to take it further, now we can actually multiply this in. So if this is over 1, then I can go ahead and multiply. Let's say negative 2 over 4. 2 times 1 is 2, and 1 times 4 is 4. And then say we cancel the 2, goes into itself once, and into the 4 twice. So this answer is then negative a half. So, or I could have cancelled over here and say 2 can go into itself once and into 4 twice, and then multiplied it out to get negative a half. Then for the third rule, of is calculated before any other of the 4 operations. So that means whenever you see of here, you have to do that calculation first. So here we just rewrite and see here's a division. Now this is also a common mistake. Don't want to change this division to a multiplication and swap these two around, because this whole calculation is fixed together. So that division actually occurs or actually applies to all of this inside this block here. So you first have to do the off calculation, and then you can do the division. So we just copy that, 3 over 5 divided by. Now when we do off and when we work with fractions, the first thing we want to do, if we see an improper or a mixed fraction, we change it to an improper fraction, because that's also easier to work with. So 2 over 5 of 1 times 4 is 4 plus 1. So that's 5 over 4. So I multiply down and I plus up to change a mixed fraction into an improper fraction. All right. So if I do off, I replace it with multiplication. So 3 over 5 divided by 2 over 5 multiplied. So whenever I see off, I can just replace it with multiply 5 over 4. Okay. Now, since we are still on this, we are going to simplify that, and we can cancel 5 and 5, and we can say 2 can go into itself once and into 4 2 times. So this is then 1 times 1 is 1, and 1 times 2 is 2. And then I can change this into a multiplication. So this is going to be 3 over 5 multiplied by 2 over 1. And then this 3 times 2 is 6, and 5 times 1 is 5. And then change it, 5 goes into 6 once, and then 1 over 5 is left. Then for rule 4, multiplication or division must be done before addition and subtraction. So this is the very first thing I think you learn from BODMAS is always multiply or divide first before adding. So that means we need to do this part first, okay? So we still write 1 over 3 plus, and then when we multiply here, we can cancel 2, can go into itself once, and into 4 2 times. So 2 times 1 is 2, and 3 times 1 is 3. Okay, now we can add, and here it's easy because the denominators are both the same. So 1 plus 2 is 3, and then that's over 3. 3 and 3 cancels, so we're just left with 1. Okay, now moving on to this one, we can see there's a plus over here, and then we have this multiplication division over here. So these guys, they tend to go together. And even if you want to make it more clear, what I like to do is to divide everything. Everywhere that I see a plus or minus, I divide, because this is one term, this is one term, this is one term. So then it's just easier for me to determine. So you simplify this, this, and this, and then you add your final answer. So all we need to simplify here is this middle term, where we still copy a half, and then we carry on. So you carry on with this calculation, and as you carry on with that calculation, you have to bring down everything that's around it. So because we have an equal sign here, it has to be equal to the next step, then the next step. So in this case over here, what are we going to do first here? I'm first going to multiply, or when you have multiply and division, we'll see that a bit later, you have to go from left to right. So I can change this into multiplication as well, but so long I can cancel these and say 2 can go into 1 and 2 can go into 4 twice. So this plus is this plus, and then 1 times 2 is 2 over 1 times 3 is 3. And then this can be changed to a multiplication. So this becomes multiplied by 3 over 2. And then we still have this plus 1 over 3. So we've simplified this part by multiplying, and we've just changed this division into a multiplication. So in our next step, we're going to multiply this out. So 3 can cancel with 3, and 2 can cancel with 2. So I'm just left with, so this gets brought down, and I'm just left with 1 over 1 plus 1 over 3. So now I need to get my lowest common multiple or lowest common denominator in order to simplify my addition of fractions. So between 2, 3, and 1, it's 6. So I'm going to say multiply by 3, top and bottom. Here I multiply by 2, top and bottom. By 6, because I want to change it into 6. Here I multiply by 2, top and bottom. And then I have 3 over 6 plus 6 over 6 plus 2 over 6. All right, so 9 plus 2 is 11 over 6, and then we can say 6 can go into 11 once, and 5 over 6 is left. Right, so now for example 4.5, repeated multiplication division is done from left to right. So here I have more than one multiplication, and what I'm going to do is to start with the leftmost one. So this is then going to be 1 times 2 over 3 times 1 is 3 times by 5 over 7. And then to take it further, 2 times 5 is 10, and 3 times 7 is 21. And then for the next one, we start by doing this one. So if I swap that around, I have 1 over 3 multiplied by 3 over 2. And I can at this point also swap this one around, but let's just take it one step at a time. So multiplying this out, we have the 3's can cancel. What I'm left with is 1 times 1 and 1 times 2. So this is a half, divided by a half. So now to change this one into a half times by 2 over 1, and then these guys can cancel, and then we're just left with 1 over 1, which is 1. Right, so now moving on to this one, from left to right, we first will be doing this part. So this is then going to be 2 over 3 times by 3 over 2, and then multiplied by 1 over 4. So these guys will cancel, and these two will cancel. So we just have 1 times 1 and 1 times 1 times by 1 over 4, and then we have 1 times 1 over 4. And over here, so now we have a bracket. So we have to do the bracket first. So here I'm going to say 2 over 3 divided. Now I can't change this before. I haven't simplified everything in the bracket first. 2 can go into itself once and into 4 twice. 1 times 1 is 1. 3 times 2 is 6. Now I can change this one over. So 2 over 3 times by 6 over 1. 3 goes into itself once and into 6 2 times. 2 times 2 is 4. And 1 times 1 is 1. So this is just then equal to 4. Example 4.6. So rule 6. Repeated addition or subtraction is done in order from left to right. So as we've seen before, if you have just division and multiplication left to right, or if you have just addition and subtraction also left to right. So but you can also add and subtract all three of these together. So it's going to take longer to do this first and then go and do that to the answer, or subtract minus 1 over 4 over with the answer. So let's treat them all together. So we're going to see the lowest common denominator between 2, 4, and 4 is 4. So I can change this into 4, top and bottom. So I have 4 plus 4 over 4 plus 3 over 4 minus 1 over 4. And then we have 4 plus 3 minus 1 over 4. So here this is applicable. So let's say 4 plus 3 is 7 minus 1. So this is then 6 over 4. Simplifying that, we get 3 over 2, and this is equal to 1 and 1 over 2. Okay, now let's look at this one. Again, our lowest common denominator is 4, so I can just change this one by multiplying top and bottom with 2. So I have 3 over 4 minus 2 over 4 minus 1 over 4. And if I put that over a long dividing line, we've got 3 minus 2 minus 1 over 4. And 3 minus 2 minus 1 is 0. So that's 0 over 4. And our answer is just 0. Then for example 4.7, if we have a fraction over a fraction, we have to simplify these fractions individually first. All right. So what I'm going to do is I'm going to say to subtract these, my lowest common denominator is between 3 and 4 is 12. So I say multiply by 4 and then multiply by 3. All right. So here we have 8 over 4 minus 9 over 12 minus 9 over 12. Right, that's all over. Now to subtract this, lowest common denominator is 6. Multiply by 3 top and bottom. Multiply by 2 top and bottom. So 3 over 6 minus 2 over 6. And then the next step, we can now subtract these fractions. 8 minus 9 gives me negative 1. So this is minus 1 over 12 all over 3 minus 2 is 1 over 6. Now if you have a fraction over a fraction, you can then expand it by saying, okay, where fraction says divide. So we're going to say this fraction minus 1 over 12 divide by the bottom fraction, 1 over 6. And then when we see a division sign, we know we have to change it into multiplication. So minus 1 over 12 times by 6 over 1. And then we can cancel. 6 goes into itself once and into 12 two times. So you have 1 minus 1 over 2 times by 1 over 1, which is then just going to be negative 1 over 2. Now, for question 4.1, we have 1 over 4 divided by, and then all of these in the brackets. So with order of operations, we have to do the brackets first. So I'm just going to write here 4.1. Then inside, so this 1 over 4, I just copy because for now we're just going to simplify the bracket. Now, before we do that, this is a mixed fraction and we have to change it into a improper fraction first. So I'm going to times down and add up. 3 times 4 is 12 plus 2 is 14. So 14 over 3 minus 2 over 3. Okay, so all I've done in the first step is just convert this to an improper fraction. Now I can go ahead and subtract these. So this is then equal to 1 over 4 divided by 14 minus 2. That gives me 12 over 3. And then I can change this into a multiplication, and it's going to be 1 over 4 multiplied by 3 over 12. And then I can go ahead and multiply these out. So 1 times 3 is 3, and 4 times 12 is 48. And then we can see if we can simplify. Actually, before we multiply it out, let's simplify it first. Let's say 3 can go into itself once and into 12 4 times, and then 1 times 1 is 1, and 4 times 4 is 16. Then for question 4.2, now here we do from left to right, since we have division and multiplication. And over here, I'm going to start by first let's just write it down here. We've got 1 over 2 multiplied by 2 over 3 divided by 1 over 3. So first we're going to do these two. And to do that, I just cancel 2 and 2 can cancel out. Then I have 1 times 1 is 1, and 1 times 3 is 3 divided by 1 over 3. This then becomes 1 over 3 times by 3 over 1. These two will then cancel. And then I have 1 over 1 times 1 over 1, so that's just 1. Then for question 4.3, 2 over 3 minus 1 over 3 plus 1 over 3. Right, so from left to right, 2 over 3, so let's do this. Let's say we have all of these are over 3, so I can say 2 minus 1 plus 1 over 3, and then 2 minus 1 is 1 plus 1 gives me 2 again, so the answer is just 2 over 3. For question 4.4, I have 2 over 5 plus 3 over 5 in brackets times by 1 over 3. So I have to, although this is multiplication, this is addition, because they are in brackets, I have to do the brackets first. So 2, these are already all over the same denominator, so 2 plus 3 is 5 over 5 multiplied by 1 over 3. Then to simplify, 5 can cancel top and bottom, so I just have 1 over 1, and then my final answer is just 1 over 3. Then for question 4.5, I've got 5 over 9 times 5 over 3 divided by 5 over 3. So from left to right, over here, I'm just going to multiply that out. So 5 times 5 is 25, and 9 times 3 is 27 divided by 5 over 3, which then becomes 25 over 27 multiplied by 3 over 5. Now I can cancel. 5 can go into itself once and into 25 five times. And then 3 can go into itself once and into 27 nine times. So 5 times 1 is 5, and 9 times 1 is 9. Right, then for question 4.6, we have 1 over 3 plus 2 over 9 over 1 over 3. So here we have a fraction, a few fractions over a fraction, and we need to simplify these, the numerator and the denominator independently, and after we've simplified them, then we can divide. Now, to add these two, we have to get the same lowest common multiple or denominator. So 3 plus 2, or let's just rewrite that first. So 3 over 9 plus 2 over 9 all over 1 over 3. So this then becomes 3 plus 2, which is 5 over 9 divided by 1 over 3. And this then is 5 over 9 divided by 1 over 3, if I just rewrite it like that. And then changing the division sign into a multiplication to be 3 over 1. And then cancel 3 here. It goes into itself once and into 9 3 times. 5 times 1 is 5, and 3 times 1 is 3. So just to write that as a mixed fraction, 3 goes into 5 once, and then 2 over 3 is left. Okay, so for question 4.7, here we have an off. So off always needs to happen first. And remember, off we change into a multiplication, and then we can put this 3 over 1. And then divide by 2. So to do this first, when we multiply this, 3 cancels with 3. So 1 times 1 is just 1 over 1 divided by 2. Now this 2 I can put over 1 and change this division sign into multiplication. So this is 1 over 1 multiplied by 1 over 2. And then to multiply that out, 1 times 1 is 1, and 1 times 2 is 2. Question 4.8, this was 7. Question 4.8 is 2 times 3 squared. Now, we have to do the inside. We simplify the inside of this bracket first. So this is just 2 times 3, which becomes 6. And then that's squared. So 6 squared is 36. Question 4.9. I have 1 over 2 minus 1 over 3 all over 6. So first I'm going to simplify my numerator and denominator independently. And this means I need to add these fractions. So to add them, I need the same denominators, which is 6. So times by 3 top and bottom here, and times by 2 top and bottom there. So I get 3 over 6 minus 2 over 6 all over 6. So 3 minus 2 is 1, so that's 1 over 6 all over 6, which we can rewrite then as 1 over 6 divided by 6, which then becomes 1 over 6 times by, if this is over 1, then 1 over 6, and then 1 times 1 is 1, and 6 times 6 is 36. Okay, so that was multiple operations. Let's look at squares and cubes. Okay, simplify. Now the cube root, what we can do first is when you have larger numbers, the best thing to do when you have a square or cube root is to actually write it in its prime factors. And 27 is 3 times 3 times 3. So that's going to be 3 to the power of 3. And then b to the power of 9 over c to the power of 6. So that's cube root. And when we take the cube root of a number, we take that exponent and we divide it by 3. So, and remember this, we need to take the cube root of all of them. We can do this. We can say, if we have x over y, and we take the root of that, you can break it up into, say, the root of x over the root of y. So if we do that, we can say the cube root of 3 to the power of 3b to the power of 9 over the cube root of c to the power of 6. Now let's divide everything by 3. So you have 3. This step you don't have to put in, but I'm going to put it in just to show you what happens. So that's 9 divided by 3, and then c to the power of 6 divided by 3. So to simplify that, we simply have 3b, 9 divided by 3 is 3 over c squared. All right, now here is an important one. We take the square root of 1 plus 9 over 16, and what normally happens is if you have a plus here, you cannot take the square root of either of these numbers, although they are perfect squares. Like for example, if I have a squared plus b squared, I cannot take the square. This is wrong. This is a plus b, so I cannot do that. I can only do that if I have a squared, b squared, like multiplied by each other. Then it's a b. But in this case, if you have a plus, you have to simplify it first. So first we're going to use fractions by putting this one over 1. Find your lowest common denominator, which is 16. So times by 16 top and bottom. So if I write that out, I've got the square root of 16 over 16 plus 9 over 16. And then adding them, I get 25 over 16, square root of that. And this is the same as the square root of 25 over the square root of 16, which is then 5 over 4. All right, so for question 5.1, we have 2 over 3 cubed. Now, when you have the cube of a number, you have to take it to all of the bases. So this is then 2 to the power 3 over 3 to the power 3, which then becomes 8 over 27. Question 5.2, cube root of 8 over 125. And in one step, I'm just going to break these up. So I'm going to write it as cube root of 8, which is 2 to the power 3, over the cube root of 125, which is 5 to the power of 3. Okay, and then divide top and bottom with this 3 here. So 3 over 3 over 5, divide by 3 over 3. So this is then, if these cancel, I'm left with 2 over 5. But once again, this step is not necessary to put in. Okay, so then for question 5.3, 1 plus 2 over 3 squared. And once again, if I have a plus b, this is wrong. Okay, I'm not allowed to say a squared plus b squared. Only if I have ab squared, then I can say a squared b squared. So when it's multiplied or divided, I can take the square in, or whatever exponent is here. But if there's a plus or minus sign between my terms, I'm not allowed to take the square in. So before you go ahead and do the calculation, you have to simplify as far as possible on the inside. And here we have a fraction. So we're going to put this over 1 and then add times by 3 top and bottom, because 3 is your lowest common denominator. So I've got 3 over 3 plus 2 over 3, and that's all squared. Then to add, I've got 5 over 3 squared. Okay, so now I can take the square into both of these bases. So I have 5 squared over 3 squared, and that gives me 25 over 9. Question 5.4. So 1 over 2, or 2.5 squared plus a half. So before we start, we have to change this into an improper fraction. 2 times 2 is 4, plus 1 is 5 over 2. And that's squared, plus, that was also squared, 1 over 2 squared. Now, taking it in, that becomes 5 squared over 2 squared plus 1 squared over 2 squared. So this is 25 over 4 plus 1 over 4, which is then equal to 26 over 4. To change this into a mixed fraction, 4 goes into 24 6 times, and 2 is left, 2 over 4. And then just to simplify this fraction over here, we have 6 and 1 over 2 left. All right, then for question 5.5, 5x to the power 3 over 3, and that's to the power 3. Now, this cube here needs to go to all of the bases inside. So this is then 5 to the power 3 x. Now these exponents multiply together, so 3 times 3 gives me 9, and then 3 to the power 3. And then I have 5 to the power 3 is 125, x to the power of 9, and 3 to the power 3 is 27. Right, that was squares and cubes. Now let's look at percentages. So example 6.1 says, write 3 over 8 as a percentage. Now whenever you have a fraction and you want to write it as a percentage, all you have to do is just to times it by 100 over 1. That's all. So then you just simplify this with your rules of fraction. So we know that 2 can go into, actually 4 can go into 8, and 4 can go into 100. 4 goes into 8 2 times, and into 100 25 times. So this then is 3 times 25 is 75 over 2. And then I can just simplify this. So 2 can go into 75. So that's the half of it. So let's just find the half of 75. 2 goes into 7. 3 times 2 is 6. Then 1 is left, bring down, so 15. 2 goes into 14. 7 times. So 7 times 2 is 14, and then 1. So basically what we have here is 37 and 1 over 2, because here's your remainder. So you put your whole number here, and then the remainder over your divider. And this is now in percentage. So just to recap, if you have a fraction, you want to write it as a percentage, you times it by 100 over 1, then just simplify it. So here we just divided, or we got 75 over 2 divided, and this is the answer that we got. Okay, so now we have a percentage, and we have to convert it back to a common fraction and then a decimal fraction. So if I have 1 over 2 percent, and remember, if you have a percentage, then if it's in percentage, you can always put it just over 100, because whatever percent you have, let's say you've got 71%, it's just the same as 71 over 100. So whenever they just give you a percentage and they say put it as a fraction, you just put it over 100. Now this is in its simplest form, you have to simplify it. So over here, let's use our fractions rules. Here we have a mixed fraction. So let's first convert it to an improper fraction, and that's the first thing we always do if we want to do calculations with fractions. So 4 times 2 is 8 plus 1. So this is 9 over 2 all over 100. And when you have a fraction over a fraction, we can expand it by saying 9 over 2 divided by 100. Now remember, as soon as you see division, and you want to put it over 1 when you work with fractions. So when you see a division, you want to change it to multiplication. So 9 over 2 multiplied by 1 over 100. Okay, and then we can write it as 9 times 1 is 9, and 2 times 100 is 200. So this is then 4.5% in common as a common fraction. Now, as a decimal fraction, what we do is we want it as a decimal number, and to do that, I'm going to write this 4.5, this 4.5 as 4.5 over 100. So to get rid of my 100 here, I can, or if I divide something by 100, then my comma moves back with the amount of zeros that I divide with. So let's put a few zeros here, because 0.04 is the same as 4. But then this is just placeholders. Then we move the comma back 2 spaces. So 1, 2. So the comma will then lie there. So this is then 0.045. Calculate 12.5% of 1,200 Rand. So when we have off, remember this changes to multiplication. So there's 3 things that happens here. This percentage, this 12.5, the percentage we always put over 100, all right? Then the off, we just replace with multiplication, and then this whole number, because we're working with fractions, I'm going to put it over 1. Okay, so there's our normal, or our sum that we need to do. Now, the first thing I'm going to do is to start by cancelling. So these zeros can cancel. That's just the same as dividing 10, or dividing top and bottom with 100. Now what I've left is this mixed fraction, which I'm going to change into an improper fraction. 12 times 2 is 24 plus 1, so that's 25 over 2, and this is just over 1, times by 12 over 1. And then we can see, can we cancel? We can say 2 can go into itself once and into 12 6 times. And then we can just multiply what's left. So if we have 25 times 6, we have 6 times 5, which is 30, and 6 times 2 is 12, plus 3 is 15. So this is then 150 Rand. So 12.5% of 1,200 is 150 Rand. Write each of the following as a percentage. Now, like I said, easy way is to basically multiply by 100 over 1. But if you've got a value that can go into 100, the other method, so let's basically do both methods. Let's say question 6.1. The first one I said was 1 over 4. So whenever you have a fraction, you want to put it as a percentage, all you do is multiply it by 100 over 1. And then this calculation is multiplication of fractions, and we can cancel. 4 can go into itself once and in 125 times. So this then is equal to 1 times 25 is 25, and 1 times 1 is just 1. So this is now our percentage. All right. So that was the first method. The other method, which you can't always use, but only if you have a number here in the denominator that can go into 100 without leaving any remainders. So this is then, if I times this number with 25, I can put it over 100. So times by 25 top and bottom. Then I have 25 over 100. And as soon as a number is over 100, I can write it as its percentage 25%. All right, so those are the two methods. Now I'm going to use the easiest method, which is the second one when we have, or let's use the first method with question 6.2, and then the second method with this 6.3. So 6.2, we've got 2 over 5, and I want to write as a percentage. All I do is I multiply it with 100 over 1. And then 5 can go into itself once and into 100 20 times. And then 2 times 20 is 40. 1 times 1 is 1. So this is just then 40%. And then for question 6.3, I've got 7 over 25. So second method, I can multiply, I can change this 25 into 100 by multiplying it by 4. What I do at the bottom, I have to do at the top. 7 times 4 is 28 over 100. So 28 over 100 is equivalent to 28%. Express each of the following percentages as common fractions and then as decimal fractions. Okay, 6.4. We have 12.5%. All right, so to put this immediately as a fraction, I can just put it over 100. So this is 12, 1 over 2 over 100. And then this becomes 12 times 2, 24 plus 1 is 25. So 25 over 2 divided by 100. And this then becomes 25 over 2 divided by 100, which then becomes 25 over 2 times by 1 over 100. So 25 goes into itself once and into 100 4 times. So this is then 1 over 8. 1 times 1 is 1. 2 times 4 is 8. So this is 1 over 8 as a common fraction. Now as a decimal fraction, I'm going to write this 12 and a half like we had it over 100, but instead of that, I'm going to write, because half is 5, so I'm going to write this 12,5 over 100, and then divide by 100, because this is now then just 12,5 divided by 100, and when I divide by 100, the comma moves back 2 spaces, which means I have now 0,125, where my comma is now over here. Okay, then for question 6.5, I've got 16 and 2 over 3, and I'm going to immediately just put it over 100 as the percentage. Converting it, we have 16 times 3, so 3 times 6 is 18, 3 plus 1 is 4, so that's 84, plus 2 is 50 over 3 over 100. So this was just converted to a improper fraction, and then we've got 50 over 3 divided by 100, and then we have 50 over 3 times by 1 over 100. So these cancel. We have 50 going to itself once and into 100 2 times, and then 1 times 1 is 1, and 3 times 2 is 6. So now for the decimal fraction, I have 16 and 2 over 3, once again over 100. Now, here's something that you can always remember. This is useful. So if you have 1 over 3, it is 0,3333 recurring. If you have 2 over 3, it's 0,6 recursive. All right. So this 2 over 3, I can rewrite this then as 16,6666 recursive over 100, and then if I divide by 100, my comma moves 2 spaces back, so I have 0, comma, and then recurring 6. Alright, so now for question 6.6, 33 and 1 over 3 over 100. So this then, 3 times 3 is 99, plus 1, so this is 100 over 3 divided by 100, which then becomes 100 over 3 divided by 100, which is then 100 over 3 times by 1 over 100. And these cancel, so I'm just left with 1 over 3. And then for the decimal, I'm just going to do it here. So if we have 33 and 1 over 3, it's this 1 over 3 I'm changing into recurring decimals of 3 all over 100. So basically what I did is just putting this in its decimal form, putting it over 100 for the percentage, and then when I divide by 100, the comma moves back 2 spaces, so this is 0,333 recurring. Okay, so here we have a word problem. Question 6.7 says a jar of marmalade contains 20% sugar, 33 and 1 over 3% oranges, and 25% lemons. The rest consists of limes. Find the mass of sugar, oranges, and lemons. Now, if I want, now in a 27 gram jar, all right, so we know that sugar is 20% of 720 of the total, right? And that the oranges is 33 and 1/3% of 720, and then that the lemons are 25% of the total, which is 720. All right, so if I want to find the grams, if my total is 720 and we need to find the amount of gram of sugar, we're basically just going to do this calculation when we say what is 20% of the total amount. So here, remember, when we do the percentage of a number, we put the percentage over 100. We change the multiplication, the of into multiplication, and we put the 720 over 1. Alright, so now let's start cancelling. We can cancel this 0 and this one. We can cancel this 0 and this 0. So what we have left now is just 2 times 20 or 72. So this is then 144 because 2 times 70 or 2 times 7 is 14. So 2 times 70 is 140, and then 2 times 2 is 4. So this is 144. All right, so this is in grams. So that's grams. So there's 144 grams of sugar. Then find the mass of oranges. So for oranges, we have 33 and 1 over 3 over 100, because this is what we're going to calculate now. What is 33, 1 over 3 percent of 720 grams? So that over 100 times by 720 over 1. Okay, so I can cancel this and this, and then I can put, so here we can also divide by 2. If I divide 72 by 2, I get 36. So 2 can go in here 5 times and in there 36 times. And this I'm going to put over as a improper fraction. So now we just go ahead and do our fractions, what we know about fractions. So 33 times 3 is then 99 plus 1, so that's 100 over 3, sorry. And that's over 5 multiplied by 36 over 1. So let's simplify this part. Here we'll have 100 over 3 divided by 5 times by 36. And then if I change this, I get 100 over 3 multiplied, if I put this over 1 over 5 times by 36 over 1. And 5 can go into itself once and into 120 times. So now I can just multiply 20 times 36. So if I have 36 times by 2, we get back to 72. So 36 times by 2 is 72. So 36 times by 20 will be 720. And then divided by 3. Or actually, before we do all of this long calculations, let's just rewrite this. This is 20 over 3 times by 36 over 1. So this thing we missed, we can cancel. 3 can go into itself once and into 36 12 times. So all that's left is then to multiply 20 times 12. So if I say 2 times 12, I get 24. So 20 times 12 is 240 gram of oranges. And then the final one is lemon. So let's just do that over here. And here we have 25%, so that's 25 over 100 multiplied by 720 over 1. Now we can immediately cancel, 5 can actually go, or let's cancel these zeros first. Then 5 can go into 25 5 times and into 10 2 times. So if I then, and then 2 can cancel, go into itself once and into 72 36 times. All that's left then is, or what this looks like now, is 5 over 1 times by 36 over 1. So 5 times 36 is 30, and then 15, so that's 180. So 180 grams. That's how much is how much lemons is in, how many grams of lemons are in a jar of 720 gram jar. All right, so now for example or question 5.8, Sila prepares a fruit drink for a party, And then we've got A, so she mixes 1 1/3 liters of oranges and then juice and 1 3/4 of liters of lime juice. How much juice is this all together? Now this is just a simple addition where we have 1 3/4 of the one juice and add another 1 3/4 of the other juice. So to add, before we add, let's convert these into improper fractions. 1 times 4 is 4 plus 3 is 7 over 4 plus 7 over 4. And this then gives us 14 over 4. And then 4 goes into 14 3 times, and 2 over 4 is left, or 3.5. Right, so that's the amount of liters she'll have altogether. Then for B, she then adds 4 1/4 liters of lemonade. How many liters of juice does she have now? So now we take what she already has, and then we just add what she has added herself. So 4 1/4. And then let's convert this again to the improper fraction. So 3 times 2 is 6, plus 1 is 7, 7 over 2, plus 4 times 4 is 16, plus 1, so that's 17 over 4. We can change this into, or when we add these, we have to get the same denominators. So this is then 14 over 4 plus 17 over 4. So what is 14 plus 17? That's 31, but 4 plus 7 is 11, and then, so that's 31 over 4. And then 4 goes into 31 7 times, and 3 over 4 is left. C, finally she adds water to make 10 liters of fruit drink. In total, how much water did she add? Now, if we have this amount of juice, right, plus some water, and the total must be 10, right? And we have here, for the juice, we've got 7 and 3 over 4 liters. What is this? So to get this, we take the 10 and we subtract the amount of juice. So here we're going to say 10 minus 7 and 3 over 4. Now to do that, we have to put both of these in its proper, or in fractions that we can work with. So this is just 10 over 1 minus, in its improper form, 31 over 4. And to subtract them, I have to multiply here with 4 top and bottom. So I get 40 over 4 minus 31 over 4. So this is then 9. 40 minus 31 is 9 over 4. So this is the amount of water that she added. So that's 2 and 1 over 4. What percentage of the fruit drink is water? So now that we know this is the amount of liters that's water, to get the percentage, we just put it, because remember the total here is 10 liters for the entire jar. So this over 10 times by 100 over 1. So if I have, just going to do it over here, if I have 2 and 1 over 4 over the total amount of 10 liters, okay, times by, to get the percentage, times by 100 over 1. This will then give me the percentage of water. So let's simplify this. We can cancel these zeros. Let's put that into that form again. So if, or the improper form, 9 over 4 times by 10 over 1, because we cancelled this 0 and this 0. And then we have, so if I cancel, 2 can go into 4 2 times, and into 10 5 times. Then I have 9 times 5, which is 45 over 2%. Alright, so that was the percentages, and then we are done with this video.